Hi folks, welcome to 4.7 practice example number 3. So we're going to take a look at this example. It says a rectangle is to be inscribed in the ellipse x squared over 4 plus y squared equals 1. What should the dimensions of the rectangle be to maximize its area? What is the maximum area? So we're going to go ahead and start with a graph, a picture of what this ellipse looks like. This is actually a really good review for Calc 2 to know what these look like, okay? So we're going to start with our graph right here of x squared over 4 plus y squared equals 1. So when we have an ellipse, the numbers in the equation are super helpful at telling us where things intersect. So I know from this equation that the x coordinates are going to be at -2 and at +2. And the way I know that is the square root of 4 gives me +2 and -2. Now by the same reasoning, I know that the y coordinates are going to be -1 and +1 because the square root of the number under y squared is 1. And then I'm going to go ahead and connect all of those to draw the ellipse. Okay. So now that I have an ellipse, let's get to the actual question. And that is the rectangle is to be inscribed inside of the ellipse. So what that means is I have some rectangle that could look like this. Okay, and inscribed just means that the rectangle fits inside of the ellipse. Now, if I think about the ellipse, there are certain coordinates that are going to be important. So, for example, I know that at any corner it touches the ellipse. I could say that coordinate is x, y. And I might not know what those numbers are, but I can tell that they're going to be an x value and a y value. Now, if I sort of take the ellipse out, or say take the rectangle out of the ellipse, then I end up with a picture that kind of looks like this, okay? And I can tell that this length here is not going to be x, but it's going to be 2x because it's like on the negative side and on the positive side. So we can say that this length is 2x. Now, similarly, I can say that this vertical side is not y, but 2y, because I have like this y part up here and then this y part down here, so there's 2 of them. Now, that leads me very nicely into the equation that I need to write. So they're asking me to not cross that out, but use the highlighter to show that I'm looking for the maximum area. So that's the equation that I'm going to write, which is the area of a rectangle. So the area of a rectangle is length times width, but in this particular case, we can say that it's 2x times 2y, or we can simplify that to be 4xy. Now, we're running into the same problem we did in number 1, which is that there are too many variables. We have an x and we have a y. And at this point in your academic career, we only know how to do this if there's only one letter on this side. So our job is to find another equation so that we can get rid of one of these variables. And after we get it into a single variable, then we can take the derivative, and then we can find the maximum point. Now, in a question like this, it turns out that this equation serves more than one purpose. This actually is our second equation. So I'm going to go ahead and write that down below. X squared over 4 plus y squared equals 1. So x squared over 4 plus y squared equals 1. Now I'm going to want to solve for one of these variables, but I want to be a little clever about how I do this because I don't want to work with too many fractions if I don't have to. So I'm going to go ahead and multiply by 4. that's going to give me x squared plus 4y squared equals 4. And then I'm going to isolate my x squared by subtracting the 4y squared. And then I'm going to go ahead and take the square root. All right, so this is a nice handy trick. You can eliminate fractions if you need to. They just make your calculations a little bit easier. And what I'm going to do is everywhere that I see everywhere I see an x, I'm going to put square root of 4 minus 4y squared. So that's going to go right here in that equation. So let me go ahead and rewrite my area equation. So area is going to equal 4 times the square root of 4 minus 4x squared times y. And that y is not under the square root. Now from here, I could use product rule, or I'm actually going to take this y, okay, and I'm going to put it inside of the square root. And here's how I can do that. If I make it a y squared inside of the square root, then I get a y on the outside. It's the same thing. So I'm going to say 4 times y squared times 4 minus y squared. And this front y squared comes from the y that I had on the outside that I moved inside of the fraction, or inside of the square root. So now I'm going to distribute this, so I get 4y squared minus 4y to the 4th, and I'm going to raise that to the 1/2 power at the same time. And the reason why I'm going to do that is so that I can go ahead and find my derivative, okay? Because remember, the whole goal here is we're trying to find our derivative, all right? So I'm going to move back up to the top of the screen where I'll find the derivative of this equation. So let's bring it back up here. All right, so we have area equals 4 times the square root of, what did I have? 4y squared minus 4y to the 4th. So 4y squared minus 4y to the 4th. Okay, and all of this is to the power of 1/2. All right, so now I'm going to take my derivative. So dA dy is going to require that I use the constant multiple rule. So I'm going to put the 4 out front. And let's take a look at what rules I might need to find this derivative. Well, it looks like I'm going to need power rule because of that 1/2. And I'm going to need chain rule because it's not just a y on the inside. So the power rule, anything to the 1/2 power is going to be 1 over 2 square root of that thing. Then we're going to multiply by the derivative of the inside piece. So that will give us 8y minus 16y to the 3rd. Okay, now from here, let's combine this into a single fraction. So I have dA dy equals, this 4 and this 2 are going to reduce, so I'll just have a 2. And then I'm going to distribute that 2 to the 8y and that 16y cubed. And that will be my numerator. So 16y minus 32y cubed over the square root of 4y squared minus 4y to the 4th. Now keep in mind that we're trying to find the maximum area. That means that the derivative at that point is going to be 0. And that means 0 equals this whole thing. Now, one really handy rule is when we're thinking about how to get 0 out of a fraction, the only thing we care about really is the numerator. Okay, so we really just want to set this part equal to 0, because as long as the top of the fraction is 0, then I know I will get 0 out of the fraction. So that gives me 0 equals 16y minus 32y cubed. And I'm going to go ahead and factor. So 16y, 1 minus 2y squared, okay? And this actually gives me two answers. My two answers are that y can equal 0, that's that y on the outside, or 1 minus 2y squared can equal 0. Now I don't want y to equal 0 because then I won't have a rectangle at all, I'll just have a flat line. So it must be this second one, okay? So we can eliminate this using reasoning. So if I solve for y in this equation, I'll get 1 equals 2y squared, or y squared equals 1/2, or y equals 1 over the square root of 2. So we found the y value. Now what we need to do is find the x value that goes with that. And what we're going to do is we're going to go back to this equation to help us find our x value. So x is going to equal the square root of 4 minus 4 times 1 over root 2 squared. And that gives me 4 minus 4 times 1/2, or 4 minus 2, or the square root of 2. So I've got my x as the square root of 2, and I've got my y as 1 over the square root of 2. Now let's go back up and read the question one more time. So this question says, what should the dimensions of the rectangle be? That means I don't want the points like I found them right here, but I actually want to find what 2x and 2y are. That way I can find the dimensions. And then how am I going to find that area? Well, I'm going to plug it into this formula, 4xy. So let's scroll back down and find our 2x, our 2y, and then our 4xy. Whew, running out of room here. Okay, so 2x is going to be 2 square root 2. All right, that is one dimension of the rectangle. 2y is going to be 2 times 1 over root 2, which is 2 over root 2, which simplifies to root 2. That's going to be the other dimension. So together, we can say that we have a rectangle of 2 root 2 by root 2. That would be considered the dimensions. Okay, now how about the area? Well, the area is just going to be the product of the dimensions, or 2 root 2 times root 2. And that gives us 2 times 2, or 4. And that is our area of the biggest rectangle that we can fit inside of an ellipse of that size. So I'm going to go ahead and zoom back out so you can see the whole problem on one page. And we're going to end this video here. Come on back for a video on question number 4. See you there.